Hey, Math 1. Today we are doing section 7.6. We are continuing proofs, and today we are going to look at what a flowchart proof looks like. A lot of students like flowchart proofs better than the two-column proofs that we have started because maybe it's a more logical way to organize their information. So let's get started. Here we go. All right, so the first thing we're actually going to do is we are going to add a tasty little theorem that I feel like maybe I haven't gone over. It's something you learn in Math 8 or maybe even before, but we need to write it down. So here it is. We're going to put it right up here. It is called the triangle sum theorem, or I think triangle, how about this? The triangle angle sum theorem. I knew I was missing something there. It is the TAST, the triangle angle sum theorem. And since we've given all of these to you in if-then statements, I will do this as well. This says if you have a triangle, I am struggling. If you have a triangle, then the interior angles have a sum of 180 degrees. Basically, it says all the angles in a triangle add up to 180 degrees. So when would you use this? You would use this if you had, say, a triangle and you knew this was 60 and this was 70, then you could get this angle. You could say that's 50, and the reason, the justification, would be the triangle angle sum theorem. All right? It would be the reason that you know the third angle. Okay, I think you're going to use that on tonight's homework. All right, so today then, we are proving that two triangles are congruent by using either a flowchart proof or a two-column proof. So there's two new things here. The first new thing is proving two triangles are congruent. We haven't done that yet. And the second thing is learning to use a flowchart proof. I think that'll go well. So we're going to start here with proving that two triangles are congruent. When you are trying to prove that two triangles are congruent, your justification for why they are congruent is always going to be a triangle congruence theorem. All right, right now, you know two triangle congruence theorems, just two. The first one we learned was the angle side congruence. All right, the angle side congruence says, if you have two triangles and that equals that and that equals that and maybe this side equals this side, then the triangles are congruent. All right? I marked an angle, and a side not between the angles. That was the first theorem we learned that proves triangles must be congruent. Again, I can't stress that enough. If you have an angle equal to an angle, and a second angle equal to a second angle, and a side equal to a side that is not between the angles, then the triangles must be congruent completely. And you get the other three parts automatically. All 6 parts are congruent to all 6 parts automatically, even though you only found 3 of them. And then we have our second one, right? Our second one is the angle-side angle congruence. And the second one, of course, says if, because we like to give these as if-then statements, if you have a triangle or two triangles, and you have an angle equal to an angle, and another angle equal to another angle, and the sides in between those angles are equal, then the total triangle is congruent to the total triangle. All right, that would be the angle-side angle. So when you are proving that two triangles are congruent, you are going to use one of these as your justification to why they're congruent in your proof. All right, so when you're trying to prove that two triangles are congruent, you are just really trying to prove that three parts are congruent to the corresponding three parts. Now, it can't be any three parts, right? It's got to be these three parts. But if you could get three parts congruent to three parts, then you could say, therefore, the triangles must be congruent. All right, let me talk about a flowchart proof, and we will get started doing three proofs, and we'll be done. All right, so a flowchart proof is similar to a two-column proof in that it has both statements and justifications. Right? The statements are inside circles, as you will see here in a second, and the justifications are under each circle. It's just a different way to write the same thing, but I'm telling you, most people like it better. All right, so here I have a proof, and we are going to do this proof both ways. We're going to do it by a flowchart proof and by a two-column proof so you can see the difference. And we're going to start with the more familiar one, the two-column proof, right? So I've been given the diagram. Now, normally this information would not need to be written up here under the given. It's in the diagram. Anything in a diagram is considered given information. So I wrote it one more time up here, just so we recognize what the given information is. But basically, the given is the diagram. And I want to focus on a key thing here. And the key thing is these parallel lines. You guys, almost any time you are given parallel lines, it is so you can use those parallel lines and the properties of parallel lines crossed by a transversal to prove that angles are equal. Let me show you. So, the first thing I'm going to say in my proof is that these lines are parallel. GH is parallel to FE, and of course, that was given. And I want to show you in the diagram how that helps us. So I want to focus, you guys should not do what I'm doing here. You should not draw it, but just watch. I want to focus on these two parallel lines and the transversal. And I want you to look at a couple angles here. Let's look at this angle and this angle. What type of angles are those that we've learned about? Well, I hope you recognize that those are alternate interior angles. And because they're alternate interior angles between parallel lines, they are congruent. So this is my point. Anytime, almost, I shouldn't say anytime, but almost anytime you're given parallel lines, that is a clue that is to help you find some congruent parts, some congruent angles. All right, so my next step in the proof is going to be those two angles. I'm going to say, let's see, that angle GHF is congruent to angle EFH. Did I get that right? And the reason I like you to put is this. If parallel lines, then alternate interior angles congruent. That really describes it. You know what that actually describes is, and you could write this instead, it describes the alternate interior angles congruence, right? It describes the alternate interior angles theorem. If you have parallel lines, then the alternate interior angles are congruent. And I think the way I wrote it is a nice, clear explanation of why those angles are congruent. All right, so let's go back to the diagram. And I'm going to erase everything except my angles are congruent. Now that we've seen how to use the parallel lines, I guess I should just erase the whole thing. It'd be quicker. And I will put those, so I've proved those. Now, what else do I know is congruent? Well, I had this other given thing. These angles are congruent, so let's go ahead and put that in my proof here. Angle GFH is congruent to angle EHF, and that was given. See, this is an example where I did not give all the given information in the first step. All right, so I have two angles equal to two angles, right? I've got this equal to this, and I've got this angle equal to this angle. Do I have any other parts I know are equal? Well, I hope you see it. It's this line down the middle. This line down the middle is in both triangles, and it's certainly equal to itself, right? So FH must be congruent to FH. I should put a bar on that, it's the segment. And I know that because of the reflexive property. We use this property all the time, even though it's obvious. Something is equal to itself. That is the reflexive property. And so I now have three parts equal to three parts. And in purple, let's make sure I've got it. I've got an angle, a side, and an angle. That is the side between the angles equal to angle, side, and the other triangle. I now have the correct three parts. I can now say that triangle FGH is congruent to triangle EHF, and that would be by the angle side angle congruence theorem. Right? This is, you're always going to use either angle side angle or angle angle side as your reason that two triangles are congruent. Okay, now let's look at a flowchart proof. Now, I put a little note down here at the bottom, which I think is important when you're doing a proof. And that is, try to plan out your proof a little mentally before you start recording anything. And I do find it helpful to like start at the end and work my way backwards. Like in this one, I know I want to prove the triangles are congruent. So I have this flowchart proof, and you see everything starts at the top with the arrows and flows to the bottom, where this bottom circle is what I'm trying to prove. It's like my final result. So I know that this is going to be what I'm trying to prove, that FGH is congruent to triangle EHF. So see how the statement goes in the circle. Now the question is, how am I going to prove that? So here's some more advice. Anytime you're trying to prove that triangles are congruent, you're going to have three circles, right, in the row above it. You need those three circles because you need those three circles to be angle, side, angle, or angle, angle, side, right? In these three circles, you need two angles and a side. so that you can then either say by angle, side, angle, or by angle, angle, side, the triangles must be congruent. Anytime you're proving triangles congruent, you're going to have three circles in the layer above the triangles being congruent. All right, so can I prove that these triangles are congruent? Well, we've already done this. I just want to show you how to write it. So, of course, let's go back to red. In my diagram, again, it was given to me that, let's go to blue. Oh, mercy. Okay, it was given to me that these angles are congruent. So let's go ahead and put that in a circle. Angle GFH is congruent to angle EHF. And I know that because it was given. So the statement goes in the circle and the justification goes under the circle. All right. I also had this other thing, this line down the middle, right? It's in both triangles. I know that FH is congruent to FH, and that was the reflexive property. All right. So I have one of my angles. I have one of my, well, my side. I need one other pair of angles. Now, what other pair of angles do I know are congruent to each other? Well, it's these one I got by the parallel lines. I know those two angles are congruent, but it was not marked in the diagram. I can't just say they're congruent. They're congruent because they're between parallel lines, right? So over here, the first thing I need is I need to say that the lines are parallel to each other. That was given. And the arrow means therefore, right? So because the lines are parallel, now I can say that angle GHF is congruent to angle EFH because of alternate interior angles between parallel lines. And there, I have everything I need. I have my angle, and my side. And let's see, the side was actually between the angles. So when I give the reason that the triangles are congruent, it would be the angle, side, angle congruence theorem. Angle, side, angle. All right, so there's your first flow chart. We're going to practice one more of those. Let's go to the back. So we are going to use a flow chart to prove that these two triangles are congruent. So I'm given the diagram, which means I'm given all the measurements and the markings in the diagram. All right, so like I said, I'm going to start at the bottom and work my way up. I know that this bottom circle is going to be triangle WVU is congruent to triangle KVM. I don't know why yet, but I'm going to look at my diagram over here and see if I can work this out backwards. So I know I have an angle equal to an angle. And since these sides are both 12 inches, I know they're equal. Is there anything else? Oh, I see it. Do you see it? These vertical angles are equal. So I am going to have, these triangles are going to be equal by angle, side, angle. I just need to organize my information. I know this is going to be angle, side, angle. So I need three circles above that they're all going to feed into that one. And these are going to be my three things that are congruent. Let's see. I know that angle W is congruent to angle K. That was marked in the diagram, so that's given. I know that angle WVU is congruent to angle KVM. Those are my red ones in the middle. Why do I know those are congruent? By the vertical angles theorem. vertical angles theorem. All right, now how do I know those two side lengths are equal? You got to be careful here. Of course they're equal. They're both marked 12 inches, but that doesn't mean they're congruent. That just means they have equal measures. How do I know they're congruent? So I actually need a couple circles up here to feed into this one. And in these circles, I'm going to put that WV equals 12 and KV equals 12 because that's what was actually given in the diagram, that they both equaled 12. And now that I know they both equal 12, can I say they're congruent? Sure I can. Now I can say WV is congruent to KV. Do you know why? Well, if they both equal 12, does that mean they're congruent? It does. They are congruent because of the definition of congruent, which is they have equal measures. So first I said they had equal measures, then I can say they're congruent because of that. And I have finished the proof. All right, and I have one more, and I'm not sure I'm going to have time, but here we go. I'm going to whip through it. So my advice here is, the reason I did this proof, I want you to see this was, these are overlapping triangles. And I think it is helpful when you have overlapping triangles to kind of pull them apart. So triangle DAB, this one, I am redrawing it so it's not overlapping, right? And then the other triangle that's sitting over here. I didn't do these very equally. Oh, that is terrible. I got to redo that one. So the other triangle over here, C and B and A. Okay, there's my two triangles pulled apart. And let's put the markings. I know that this angle with two things is equal to this angle with two things. And angle A with one thing is equal to this angle B with one thing. There's the markings. So, do I know that these triangles are congruent? Do I have a third part? I have two parts congruent to two parts, but I need a third part. And I see it. The third part is this line down the middle that is in both triangles. This side is equal to this side. So are those going to be congruent triangles? And by what by angle, angle, side. So now that I've kind of planned that out, I can start doing my proof. Let's see. Angle D is congruent to angle C. That was given. Angle B is congruent to angle A. That was already given in the diagram. A congruent to B. And the sides are congruent. See, AB is congruent to AB. Do you remember why? Everything is congruent to itself. That's the reflexive property. And so here's my three statements. I have three parts equal to three parts. So I know the triangle ADB is congruent to triangle BCA. And let's get this right. Angle, angle, side. The angle, angle, side congruence theorem. All right. You will practice doing some proofs on tonight's homework. We'll talk about them in class. Good luck.